Hey everyone, and welcome to today's Explainer. We are laying out a highly energetic, step-by-step blueprint tailored specifically for aspiring engineering students looking to launch a high-growth career in India's booming drone industry. If your goal is to design, build, and legally fly the absolute future of aerospace, well, you are definitely in the right place.
Let's just jump right in with a massive number. India's drone sector is projected to create over 100,000 jobs by 2030. Think about that for a second. That means incredible opportunities are opening up for your career right this very minute. And we aren't just talking about your average flying toys here. We're talking about incredibly complex, industrial-grade systems that are literally reshaping entire sectors of the economy.
Here's our roadmap for this explainer. We're going to cover the booming Indian drone industry, look at top engineering roles and salaries, break down the essential drone engineering skills, walk through the DGCA license checklist, take a look inside DGCA pilot training, and finally, talk about launching your high-growth career. Let's get to it.
All right, starting with Section 1, Booming Indian Drone Industry, Sector Trends and Demand. We really need to understand exactly why this tech field is exploding across the country.
So, what's driving all this demand? It's all about massive real-world applications. Government initiatives like the Namo drone Didi scheme are equipping thousands of agricultural workers with drones for crop spraying. At the exact same time, you've got the Swamitha scheme mapping millions of village properties. Add in large-scale infrastructure inspections, expanding beyond visual line-of-sight logistics networks, and high-tech defense surveillance, and you suddenly have an urgent, immediate need for certified professionals who understand both the hardware and the data.
Moving right along to Section 2, Top Engineering Roles and Salaries, Mapping Your Financial Potential. This is where your engineering degree really starts paying off. Let's compare the entry-level baseline with your future potential. As a fresher, you're looking at solid starting salaries in the range of 4 to 8 lakhs per annum. But as you gain specialization and start hitting those senior roles, you can easily command 20 to over 50 lakhs per annum right here in India. And if you zoom out globally to organizations like NASA, well, that can reach up to an incredible 1.4 crore. And it really gets interesting when you look at who's actually hiring. Notice the stark contrast in salary ranges here. Private giants like Boeing and Airbus are dropping averages around 16 to 17 lakhs per annum. But then, if you're leaning toward pure research and incredible stability, esteemed government bodies like ISRO and DRDO offer typical starting ranges between 7 and 13 lakhs. It really just depends on the kind of environment you want to build your career in. Now, if you were plotting out your long-term career planning, notice how specialized engineering roles sit at the very top of the pay scale. Flight test engineers and propulsion engineers are pulling in top-tier numbers, often averaging 16 to 18 lakhs. The takeaway here? The deeper your technical expertise in a specific subsystem, the higher your value is going to be to these aerospace companies. Which brings us to Section 3, Essential Drone Engineering Skills, Building Your Technical Toolkit. Let's shift gears and talk about the hard technical skills you actually need to master. Major aerospace companies expect you to bring some serious technical firepower to the table. We're talking sensor fusion integration, advanced PID flight control programming, complex propulsion design, and AI for autonomous navigation. These aren't just nice-to-haves, they are absolute non-negotiables. It's not just about flying the drone, it's about mastering the math and physics that keep that machine stable and intelligent in the air. And to back up those skills, you need the right software stack on your resume. If you want to excel in design and simulation, you gotta be proficient in CAD tools like CATIA and SolidWorks. You need simulation software like ANSYS and MATLAB. And frameworks like the Robot Operating System are totally essential if you want to be the one designing the next generation of UAVs. All right, on to Section 4, the DGCA license checklist, your legal roadmap to the skies. Because honestly, none of your engineering skills matter if you aren't legally certified. Before you even think about applying, you must meet some strict foundational eligibility standards. You've got to be between 18 and 65, have passed at least Class 10, and hold a valid medical fitness certificate, plus your standard government ID. And actually, here's a crucial detail. If you're buying a drone for commercial use, like an agricultural sprayer, it absolutely must be a DGCA type certified model. Seriously, do not overlook that detail. Okay, here is your literal turn-by-turn roadmap for the license application. First up, get yourself registered on the EGCA portal. Second, register your drone to get a unique identification number, or UIN. Third, knock out your training at a DGCA-approved remote pilot training organization, or RPTO. Fourth, pass those theory and practical exams. And finally, receive your remote pilot certificate, the RPC. Let's zoom in a bit for Section 5, Inside DGCA pilot training, mastering the mandatory modules. What does this training actually look like?
So during your 5 to 7 days of intense training, you're going to cover some very specific academic and practical modules. You'll study everything from air law and UAS regulations to meteorology and aerodynamics. Then you'll hit the flight simulators before moving on to practical, hands-on flight and payload operations. It's basically a highly condensed crash course in aviation safety. Now, for the exam itself, here's a quick cheat sheet for you. You absolutely have to know the difference between these two acronyms. Think of the UIN, the unique identification number, exactly like a license plate for the drone hardware itself. And the RPC, the remote pilot certificate, that's your personal driver's license to fly it. They're totally separate requirements, and you need both to operate commercially. You're also going to need to memorize the digital sky airspace zones. Flying commercially without checking these, yeah, that's a massive legal violation. Green zones are free to fly up to 400 feet. Yellow zones mean you need advance permission. And red zones, strictly restricted no-fly areas. Literally always check the map before you launch.
Let's bring it all together now in Section 6, launching your high-growth career, the value of certification.
So why go through all this trouble? Well, the financial payoff is huge. Certified professionals make, on average, 28 to 35% more than uncertified operators. And because the training costs are relatively low compared to traditional aviation, corporate operators are often recovering their training costs in as little as 11 months. That is for sure one of the fastest return on investments in the tech sector today.
But since we're talking to aspiring engineers here, you've really got to ask yourself a tough question to stand out in this market. Anyone can learn to push joysticks. Are you just going to be a pilot? Or are you going to leverage your engineering toolkit, your knowledge of sensor integration, CAD software, and data analysis to become an invaluable systems expert?
I want to leave you with this incredible insight to keep in mind as you launch your career. Certification creates trust, but data skills create value. Get that DGCA license so you can operate legally and safely. But lean hard into your engineering fundamentals, your data processing abilities, and your deep technical skills to truly dominate the industry. What new solution are you going to engineer for the skies? Thanks so much for joining me on this explainer, and I really hope this gives you a clear flight path for your career.